Howdy folks. Today on the bench we have a Chinese LED power supply which is originally rated at 36 volts and 11 amps. Today I'm going to be modifying this charger to be adjustable both in voltage and current, and so that I can use it to charge my electric moped, which is using 36 volt batteries hooked in series for 72 volts. To start with, we're just going to have a look at the circuit, take a look at the components used, and just figure out what we actually have to change in order to make this adjustable current and voltage. Starting from the front, we have our terminals for input and output, so AC input on this side, DC output on this side. We've got a minor voltage adjustment potentiometer there, which forms a voltage divider with resistor 40. So by adjusting those two values, we can change the output of the power supply in terms of voltage. Moving back, we have our filter capacitance, three 1000 microfarad 63 volt capacitors, branded, just some Chinese brand. So not the most trustworthy, but there is 3000 microfarads of capacitance there, so they haven't skimped out. Big doubled over inductor for filtering of any switching noises. Moving back, actually I missed something important. The current shunt is there. I'll touch on that later. We've got a diode here. The part number is 40 and 30, and that is actually a 40 amp 300 volt diode, so way overrated for what we're using, but that's good. We've also got our AC filtering here. I've added a little bit of hot glue to this just because stuff was shaking around a bit, specifically the ferrite on the inductors and that bridge rectifier. Moving backward, we've got our 110/220 volt switch, some more power supply filtering, so our big input capacitance. We've got our switch mode transformer, and I believe that's rated at 400 watts. It's not too small, but I'll have to really test it to make sure of that. Our main power supply chip is, can I read that? It's a KA750, 7500 rather. So that's just a standard switch mode power supply chip that they use in like old power supplies and things. We've got a driving transformer for powering the main switching transistors in this case. They're not MOSFETs or IGBTs, they're just NPN transistors. And they're rated at 12 amps continuous current and 700 volts max. So, aside from the voltage regulation, we also have current regulation. Using the voltage drop across the current shunt, it is fed back through resistor 35 there, just in the center of the frame, and then resistor 21 in the center of the frame. Those two make up a voltage divider, which gives current feedback to the KA7500, and by adjusting the value of R35, we can change the current output of the supply. That's something we're going to be doing today. I'm going to begin the modifications by heating up my soldering iron so that I can remove this. It's a 1 kilo ohm potentiometer here. I'm going to remove it and replace it with a 10 turn 5 kilo ohm potentiometer. And this resistor over here, I think it's a 750 ohm resistor, and I'm going to replace that with a 5 kilo ohm potentiometer to change the current. Now, for both of these, I'm going to be removing the original resistance and then just soldering the potentiometer on top, just for simplicity. While the iron's heating up, I think it's worth just having a look at the back of the circuit board. So you can see the main high current traces are all doubled up with a little bit of solder, and you've got your feedback wires going back to the circuitry. That one's for voltage. You got another one for current over the other side, just where I focused on there. The one thing I have noticed is that where the main high voltage transistors are, there is a spot with very small distance, and that's going to potentially have hundreds of volts across it, and that is definitely something to be wary of. That they've snipped the wires off there, and there's so little space there that if there's a voltage spike for any reason, that could arc and then damage the power supply. So I'm just going to cut those leads a little bit shorter for safety. Okay, the iron's hot enough now. I'm going to go in, heat up these 3 pads here, and remove, it won't focus, sorry, but I'll remove the potentiometer. Okay, having removed the potentiometer, I bent the wiper leg of the potentiometer over, soldered it to one of its adjacent legs, and now I'm going to solder it onto the circuit board. Let's do it. Okay, the first step is done. The new potentiometer for adjusting the voltage is installed. Now, let's move back to between these 2 capacitors and install the new potentiometer for R35. Okay, rather messy soldering job, but the resistor is removed. Okay, I'll install the new potentiometer. All done. Our current adjustment resistor is installed. There we go. Okay, now it's time to put the power supply back together and give it a go. Okay, the power supply is back together. I've reinstalled the heat sinks for the diode and the 2 transistors. Now, because I am away from my normal workbench, I don't have heatsink grease, but generally, when you get these supplies, they don't put much heatsink and grease, so you should put some between the mica insulating pad and between the 2 aluminium surfaces, and that's for the diode and the transistors. In this power supply, I expect the diode to get the hottest because they have a considerable voltage drop. Actually the transistors might be similar as well. I haven't really tested this one properly yet, but now that it's back together, I can give it a go. Don't forget to install the 4 screws around the base. So 1, 2, 3, and 4. There you go. So I've got my 2 adjustment resistors there. I'm going to keep the supply open until I've adjusted it to the perfect voltage and current. But otherwise, there we go. It's all set.